Okay, we will start our session. So, hello everyone. Good morning, good afternoon, good evening to all. Dear authors and invited guests, welcome to the technical session by C. I am Riddhi Gohel, moderator of this session. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome to the 6th World Conference on Smart Trend in System and Security and Sustainability through Zoom. I hope you will enjoy the knowledgeable and interactive session through the day. There is a special note for the presenter. You will be given 12 minutes for the presentation and the 3 minutes for the question answer. And on 10 minutes, I will raise a gentle reminder to conclude our presentation. And there is a one special request to all, please stay connected with us until the closing remarks. If you have any query and update, please let me know in the chat box. So just before we get started, I would like to introduce to all our session chair, Professor Om Prakash Rishi. Hello sir, I welcome you. So, Dr. Rishi is presently working as a Director IT, University of Utah. His area of research interest is intelligent system and IT, case-based reasoning, AI application, cloud computing, and e-governance. He has published 40 research papers in an international referred journal and 30 research papers in an international conference proceedings, and also received 2 Best Paper Awards. And he has also published 8 books. So, can we start our session, sir? Okay, our first presenter is Jiahang Wang, and paper title is Robot Wheel Controller System.
Hello, everyone.
Hello, ma'am.
I'm trying to share my screen. Hi, everyone. Thank you for your attending. My paper article is Robot Wheels Controller System. I am Xuehong Wang.
Ma'am, sorry for the interruption. Can you please make a full screen?
Sorry?
Make a full screen.
Full screen. Okay, no problem. Let's start from this page. The first part is introduction, and second part is the introduce the mechanism wheeled robot moving model and analysis. The third part is the control systems introduction. First, we introduce the transfer function, and then is PID controller. The third one is the fuzzy neural network controller. The first part is controlled system simulation and the performance analysis.
No laugh.
The mechanism wheeled robots are popular used in the world. Some people, there are many kinds of mobile robots. Some researchers they use wheeled, track, and leg, but in our study we use the mechanism wheeled. The mechanism wheeled, there are some advantage for the robot. It can increase the mobility, and it can drive to any direction. It can also do not need too much maneuvers for the path tracking task. In this paper, we introduce the mathematical model for the mobile platform, and we introduced the 2 controllers. One is PID controller, another one is fuzzy neural network controller, and we also simulated the performance for them and compare the results for them. This is the model for our mechanism wheels. It's from the facing ground view. It's not for the top view. From A, we can see it's driving in front. Picture B is driving left. Picture C is driving diagonally. D is driving rotation around the left edge. E is rotation around the center of the platform. F is the platform is rotation around the bottom edge. This is all the parameters we are going to use in our papers. See, the R is the radius for the mechanism wheel. Vx, Vy, they are the speeds of the wheels in axis X and the axis Y. VR is the rolling speed of the active roller. Omega is angular velocity of the mechanism wheel. Theta is the angular of the roller and the axis X. From the above, the parameters, we can get the equation 1. We called the left front wheels is wheel 1, the right front wheel is wheel 2, left rear wheel is wheel 3, the right rear wheel is wheel 4. D is the width of the robot platform. L is the length of the robot platform. The capital X, capital VY, they are the speed of the robot in axis X and axis Y. The psi is the turning speed of the robot. This is the equation. We can use this the same equation to show the omega 1, 2, 3, 4 for the 4 wheels. According to above of the equation, we can get the all the omega parameters. So omega 1, omega 2, omega 3, omega 4 is for the angular velocity for the all 4 wheels. We get the, and then we get the, we can get the results with result for the omega 1, 2, 3, 4. For the robot, when they move in the y-axis with the speed of v, we can get the result omega 1, 2, 3, 4. They are same results. When the robot they are moving along in axis X with speed v, we can get the result omega 1 is the same with omega 4, omega 2 is same with the omega 3. When the robot is turning around the center with the angular velocity omega r, we can get the results in the follow. For the mobile platform, the movement can be achieved through controlling the angular velocity of the 4 mechanisms with omega 1, omega 2, omega 3, omega 4. Because the motor, they can be controlled separately. So in our articles, we are going to analyze the single wheel and apply them to other wheels. For the design, for the controller systems, for our robot platform, we are going to use this transfer function. And from this part, we can see we will put our controller in the middle parts. From omega s is target result output, and omega s is the real target. We want to see get the same or similar result, so we must put the controller in the middle parts. we are going to put a PID and a fuzzy neural network controller in here. The PID controller, we can get these equations. So when we setting the response, assume nu is 0, omega s is the unit step signal, we can get the PID controller equation in the follow. And based on the Hurwitz stability criteria, we need to keep all the parameters, they are bigger than 0, then we get the result for equation 10. With the disturbance response, when omega s is 0, nu is a step signal. We get the same result with above equations. So we want for the following PID controller system, for the parameters, we are going to choose the parameters be satisfied with these conditions. This one is for the fuzzy neural network controller. The I is in for input, O is for output. This is three different equations. They showing the input layer, hidden layer, and the output layer. The E is and EC, they are the error and the change errors. W and V, they are the weights for the neural network. F psi I is the hyperbolic tangent functions. We are trying to get the weights for W and V. So with the fuzzy rows table, we can get the results for the equation. Is for this one. We are going to get the result for the UPS.
Hello, ma'am. Sorry for the interruption. You have 2 minutes left.
Okay, thank you. And according to after training the data from the neural network, we can get the result for figure A, B, C. Figure A show the training performance. B is the training target, and the real output before training. And C is the after training, the target and the real output. We can see the C is much stable than B. Follow is the simulation for the performance for the two controllers. This one is for we get the best value for the KPID values. We can see the this picture for when we put the PID controller, we can see how is the performance of our robot. This one is for when we use the fuzzy neural network controllers for our mobile network. A is the picture. A is the performance for training. B is the target. Is the output with disturbance signals. The picture C is comparison with the PID controller and FNC controllers. We can see from this picture, the mobile platform come with fuzzy neural network is much stable and faster than the PID controller. The last part is for the waypoint tracking. We can see the capital VX, VY side. It can decide the value for omega 1, 2, 3, 4. And this part is they show the how to get the position for our target. This articles we we study the different angular velocities for the four wheels. They can determine the speed and the direction for the mobile platform. The result of the simulation shows the traditional PID controllers and FNC performance. The fuzzy neural network controller is overperformed than the PID controller. A fuzzy neural network controller is stable and faster than PID controller. Thank you.
Yeah, Wang. I have certain queries with you. You
Yes.
have discussed about Magnum mobile platform.
Yes.
Yeah. So how it is different with other platforms?
Sorry.
How it is different with other platforms?
Other performance.
Yeah, other platforms. Like
in our.
Yeah, please.
Yeah, yes, please, you can ask. In our articles, we put the PID controller and FNC controller. The PID is a traditional controller for the robot.
Okay.
But we want to try to improve the platform for it much more stable.
There is one more. There is one more platform. Are you listening me? There is one
yes.
more platform, that is Arduino Mecanum platform. How?
Yes.
Have you ever heard about it?
And for the traditional.
Mecanum.
Yes, for the traditional one, there are some weakness for it, like it's shaking or take time to find to go to any directions. But come with the fuzzy neural network, it will be more fast, more stable, and try to reduce more disadvantage for the traditional controllers.
Okay, thank you.
Thank you.
Thank you, ma'am.
Okay, thank you, ma'am.
Thank you.
Yeah, we are moving our next presenter. So our next presenter is Vasilios, and paper title is Earthquake Monitoring with Mem Sensors.
Hello, I'm sharing my screen. Does it appear correct?
Yes, sir.
Okay, thank you. Hello, everyone. My name is Vasilis Konstantakos. I am from Greece, Aristotle University of Thessaloniki, and I will present you my work with title Earthquake Monitor with Mem Sensors. Earthquake monitoring has always been a significant process for public safety, and with many existing and well-proven instruments in their quality, but rather big in size and weight, also a lot of expensive, and with energy needs that you cannot describe as minimal. At the same time, there is advanced progress in instrumentation system design, and especially in Mem Sensors targeting earthquake monitoring. And the thing is that you cannot use general purpose Mem Sensors for earthquake monitoring because the earthquake signals that must be recorded are rather low in amplitude, and they're characterized by frequencies close to 1 Hertz. And in general purpose MEMS cannot perform that well with these specifications. Thus, we are using specialized advanced MEMS sensors in order to create an earthquake monitoring device with MEMS sensors. The case study is the evaluation and the safety of school buildings. Some design characteristics are the following. First of all, the modes of operation. The system may operate in a continuous mode, which is the normal earthquake monitoring case, a device that monitors at all times. But at the same time, it can operate in a non-continuous mode, meaning creating on-demand recordings. And imagine that, for example, if you have a school, you may place one instrument in a key location in order to track earthquake signals. But at the same time, you may use multiple of these devices throughout the school building on different floors, on different locations, and request on-demand acquisitions of a few minutes in order to analyze afterwards the structural integrity of the building, either during an earthquake or after an earthquake. In general, there are also other variations in the operating conditions of such systems, and they all share. We try to make a common design in all these variations. All these variations share the same core process, which is the acquisition process. And after that, there are some added functionality that is being used on occasion, like low power guidelines. The sampling rate is 200 Hertz. And a question that we needed to answer at the end is if such a proposed design will be able to provide instruments capable of replacing the existing earthquake monitoring devices. Here you may see the system architecture. On the left side, there is the complete system. The key device is in the middle, the accelerodgraph. And within the accelerodgraph, the important module is the measuring node, which appears enlarged on the right side. Also on the left side, on the top, there is the base, which is mostly a Raspberry Pi that is able to communicate with the accelerodgraph and at the same time with the network. And also we are using a GPS module. The core measuring node appearing on the right is mostly the central microcontroller, a low power microcontroller from Texas Instruments, an SD card for local storage, a wireless module CC2500 for some proprietary wireless communication, and two MEMS sensors. The important one is the ADXL355, which is the one that targets earthquake monitoring. And the other one is a general purpose one, ADXL362, that we use in the purpose to be able to wake up a system that sleeps with a reduced energy consumption. Other than this, there is also, the system operates on a lithium battery of 3.7 volts, and there is a harvesting logic on the system. Here you may see the implemented system as it is already made and operating. Some important aspects of the implementation was the need for accurate internal time. When you have a system that operates continuously for months, it is easy to have the time drift, and the drift of time is really something that the earthquake network does not want. So we needed to add the GPS module and a proper internal algorithm in order to create an accurate internal time. At the same time, the system must be operating in a robust and uninterrupted way because of the nature of the earthquake monitoring. Most of the times, the earthquake instruments are placed in locations where it's not easy to access after the installation. Thus, it's not easy for a human user to troubleshoot it if something goes wrong. And the data provided by this device must be uploaded directly to the seismological network. Thus, they are shaped in a proper format, miniseed, and are uploaded to the Ethernet. Now, for the non-continuous operation, we are also interested in the low power behavior of it. Thus, we are utilizing high levels of low power sleeping modes. And when such a system sleeps, we need to define some ways of waking up. There are two ways. One is by the ADXL362, as mentioned already, by detecting local vibrations, then the system wakes up, and the other MEMS, which is the most quality one, takes charge in the acquisition. Imagine that the ADXL362 consumes only 3 microamperes, while the ADXL355 consumes 200 microamperes. And the other one is the ability to wake the system through wirelessly with the help of this wireless module, CC2500, but with the help of a wake on radio operation, meaning that this wireless mode is not always operating. It's operating at a specific percentage, like 3% of a 2-second cycle, meaning the consumption is really reduced, and we have now the ability to wake up the system wirelessly without consuming the battery. Here are two pictures of the system as it was evaluated on the laboratory with the help of a vibration table. If you observe at the middle of the picture, this is a reference earthquake monitoring device. It's really large, it's really heavy, and it's really expensive. And on the right side, it's a photograph from the school installation of the device. Now, we needed also to evaluate the time error, how much the internal time is different than the GPS time, and it was measured to be at all times lower than 3 microseconds. As far as the energy consumption is concerned, we needed to evaluate especially the core measuring node, because it's the part that will be used in the non-continuous operation. And we did an average current measurement of each submodule on specific operating states. There are two important states, meaning the lowest consuming state is the idle state, where everything sleeps except the triggering hardware. And we see that in this case, we have a consumption as low as 25 microamperes. While on the acquisition state, everything is on. We did not try to optimize in this state much because we wanted not to deteriorate at any chance the quality of the acquired data. Now, this also device is being combined, as mentioned, with harvesting logic. The most frequent available energy source within schools is light. Thus, we made a lot of different approaches to harvest a light source either from indoor or outdoor locations. On the right, you see a table that's indicative of how much power is gathered by such an approach. And according to the specific details of its location, in many cases, the device became energy independent based on this harvesting logic. Now, as far as the experimental values, the acceleration values are concerned, we evaluated the ADXL355 mostly in comparison with a reference existing earthquake monitor instrument, which is called GURALP in this slide. And we also took into consideration a bit the ADXL362. On the left side, you see the noise levels. The GURALP shows the best performance. And the ADXL355 is a bit worse, but not that far from the GURALP, while the ADXL362 shows levels that are a few times more than the above two. And on the right side, you may see a simulated earthquake as created on the vibration table on the laboratory. And all three devices showed something quite similar, either looking at the time domain or looking at the frequency domain. At the end, as mentioned, we installed the system in a school building, always together with a reference earthquake monitor so that we can have comparisons. And eventually, a few earthquake events were recorded. Here is one, and we can see the X, Y, and Z axis on the GURALP and on the ADXL355, the curves as someone can see them, but also on the analysis that the scientists ran on the earthquake research area showed that it's quite good. The performance of the ADXL355 is quite satisfactory at the only expense of some increased noise that you may see on the thickness of the curves on referring to the ADXL355. So in conclusion, an earthquake monitoring instrument was developed with case study, the school buildings and the safety of them. we tried as best as we could to create a common design for every possible variation of operation. The quality of the acquired data was quite good, and the quality also of the low power behavior was quite good. And the answer to the original question is that the proposed design can be a possible replacement of existing earthquake instruments, as it was answered not only by me being not really on the earthquake area, but also by scientists that work on this data and these instruments. Thank you very much.
Yeah, dear author, you have done a great work, but I have few questions in my mind. You have taken sample rate is to 200 hertz. What is the
Yes.
basis of it? What is the basis of it? In place of 200, can we take 180 or 220 like that?
Well, the discussion we had with the scientists mostly dedicated to earthquake monitoring said that the frequencies that we are interested in tracking are close to one, close to a few hertz. Thus, they were satisfied either with 200 hertz. The most that the earthquake monitoring devices provide is 1000 hertz. It's not frequent to have more frequency values than 100 hertz, and 200 hertz was a value that we agreed because we wanted to be a bit conservative, at least at this case, on the because systems must work at this frequency at all times. So wanted to be a bit conservative, but without making sacrifices. It felt satisfactory to them, so we took it.
And similarly, one more query. You have computed evaluation of time error. Time
Yes.
error you have computed. Yeah. How it is computed?
In a process, in a bit more advanced process, where we tried to get more frequent updates from the GPS signal. The GPS provides a PPS signal, meaning one signal every second. And on this measuring process,
you have taken samples from GPS.
One sample, one hertz per one sample per second. But we tried, and we are trying to make corrections within the tool. It's a low power microcontroller. It does not have a high frequency clock. So we tried to make an internal accurate timing, some corrections based on this refresh once a minute. And then we tried to implement a small added algorithm that tries to understand what are the corrections it makes at any time, meaning if it's a really relaxed part, then not many.
Which algorithm you have adopted for this? Which algorithm you have adopted?
It's a custom. It's something custom. I don't have a name for it.
Okay, you have customized it.
Sorry?
You have customized this algorithm for your data.
It's a fully custom algorithm. It's a fully custom program within the microcontroller that tries to make this correction.
Okay. Thank you. Great job. Congratulations.
You're welcome.
Thank you so much.
You're welcome. Thank you very much.
Yeah, thank you for your kind presentation, sir. So our next presenter is Anika, and Pepper Data is Data Medi, a web database system for e-health.
Yes, ma'am, I am here.
Yeah, ma'am, you please start your presentation.
Can you see my slide?
Yes, ma'am, it is visible.
My topic is Data Medi, a web database system for e-health. Here are three authors: I am Anika Tabassum. Now I am presenting here. Another one is Tahmidul Islam. He is also present here. And another one is Tamsit MD Niamatullah Akant. Abstract of our system. We work to develop a system which is to gather all types of information in one system so that doctor can view any type of information at any type. This work is cost-effective, smart, secure, and maintainable web-based health history management system for doctor, patient, donor, pharmacist, and general health concerned people. The main purpose of our system is to get a multi-user web-based patient database system. Doctor can easily prescribe patient and patient can easily view their own records so that it saves time and risk both doctor and patient. The system requirements of our project is in backend programming language, we use PHP and JavaScript. For front-end programming language, we use HTML and CSS. Our local server is XAMPP and our database is MySQL. For better understanding, we use here UML diagrams. From here, I will discuss methodology of our system. Now I'll discuss use case diagram of patient. First of all, patient will log in the system by using their verified username and password. If username and password is wrong, then system will go back to here the login page. User can change his password if you want. Patient can view medical records and can also update personal information like address, email, contact number, etc. Patient can also print prescription if you want to a hard copy of prescription. The use case diagram is doctor and assistant. There is two type of user, and first I will discuss about doctor. After logging the system, doctor can view patient records, prescribe medicine, and can change power of medicine. Doctor can also search donor list, view donor list, and also contact donor in emergency case of patient. Sometimes donors willingly wants to donate their blood or plasma. Nowadays, doctors are too much busy to check and visit patients. So here I put another user which is assistant. Now I'll describe about assistant. After logging the system, assistant will put prescription into our e-health system. Now I'll discuss about the pharmacist. Pharmacist will log in the system. After access the system, pharmacist can view patient prescription, can give medicine according to prescription. Here is the algorithms of our system. Now I will discuss this algorithm. By using verified password and username, user will access the system. If user ID or name is wrong, then the system will block for 3 minutes. After successfully login, if user type is doctor then and patient ID is valid, then doctor can view patient record, can change power of medicine, and can give prescription. If donor ID is valid, then doctor can view donor record, can contact donor. If user type is patient, then patient can view their own medical records, update personal information, can print prescription. If user type is pharmacist, then patient and patient ID is valid, then The pharmacist can view the patient prescription, can give medicine. If user type is assistant, then and patient ID is valid, then assistant can input prescription into e-health system. Now I will discuss the output of our system. First page of our system is login page. In figure 1, by using user ID and password, user can log into the system. Here is an admin who hold the system. From figure 2, admin can add user, and from figure 3, admin can manage user. Admin can check how many users in the system. From figure 4, doctor can view the prescription list, and from figure 5, doctor can also view the test list. From figure 6, doctor can add prescription, and from figure 7, doctor can update prescription when doctor change the power of medicine. From figure 8, doctor can add test, and doctor can also view the donor list by using donor type or blood group. From figure 10, assistant can add prescription, and from figure 11, assistant can update prescription. From figure 12, pharmacist can view the prescription list, can give medicine according to the prescription. From figure 13, patient can view medical test and can print own medical records. From output section, we can see there are many features in our system. Now I will discuss about the features. All types of disease information like test report and medicine of our system, patient can be saved in the system. Patients can view their own records, prescribed medicine, and can update own personal information, can print prescription. Doctor can also view patient records from the system, prescribe medicine, and can change power of medicine. Doctor can also search donor list, contact donor list. Assistant can input all information in the system from prescription. Pharmacist can view patient's available information. Pharmacist can keep patient medicine record according to prescription of the database. E-health system is already exist. Now I will discuss the difference with other medical databases. Users like assistant and pharmacists are not in any other system. Patient information is not kept in this large scale in any type of database system. Patient personal information is saved in our database. Patient can print own prescription. Unlike most database, this database is user friendly and is multi-user system. It can be used nationally. Unlike other database, it allows pharmacists to view patient prescription to give medicine. In this slide, I will discuss the social impact of our system. This system will improve patient care because unlike available database, it has extra user like pharmacist and assistant who play big roles. It will save time of all relevant user like doctor, pharmacist, and patient. The pharmacist can give medicine more easily. Doctor can prescribe perfect medication and patient records will be saved. It will play a crucial part for future diagnosis of patient. In this slide, I'll discuss the limitation of our system. Number of features for our users are limited. Security can be increased more. Why? If we design it with JavaScript or Ajax, it will be more eye-pleasing. MAMP or Laragon could be better jump substitutes. In this slide, I'll discuss the future work. Patient security can be strengthened by sending one-time password to patient phone for user verification. Pharmacist can get notification if a patient in his area got prescribed any random kind of medicine. Patient can check availability of medicine in nearby pharmacies. Machine learning approaches can be applied on stored data. Now I'll discuss the conclusion of our system. This work developed a smart web-based structure of patient database system where all types of information are organized in one database. All users can view correct needed information. Records can be accessed in anywhere and anytime. No more relying on analog records. It will be beneficial for all the users. Patient's information would be safe and intact. Thank you, everyone.
Yeah, Anika, you have done a great job. You have developed a software and you have given presentation on that. Yeah, I'm correct?
Yes.
Okay. So what is the research of it within your this presentation? Is there any innovation? Is there any new concept, or is there any algorithm developed by you? What
Yes,
are the research aspects within this?
here is a custom algorithm which I developed here, and can you?
I think
cannot
I think lot of software already exists, and
Yes.
you also mentioned that this system can be used nationally. But I believe that if you have developed any of the software that will work internationally, whatever concept we develop that can be used at internationally, people can be benefited for that. So I doubt on that. How can you justify?
Yes, in
Robot?
our system, assistant and pharmacist is already exist. In another system is not assistant, because we add assistant because nowadays doctors are too much busy to visit patient. So assistant will prescribe medicine input to the system. Assistant is a new feature, and also pharmacist is a new feature. And in another system, there is no type of in our system, patient can input personal information, which is very much important, and patient can print his own prescription.
Your
Patient
title is
information.
okay. Just I got it. You within your title you mentioned that a web database system for e-health. What do you mean? Can you explain e-health?
Electronic health system.
What does it mean? Health can be electronically measured, or can be monitored, or can be controlled, or what exactly you want to say here?
Health record kept digitally.
Okay. Thank you, Anika. Thank you so much.
Thank you. Welcome, everyone.
Thank you, Anita. So we are moving on next presenter. Our next presenter is Nikolaus, and paper title is Interruptible Stroke Risk Prediction using Machine Learning Algorithm.
Good evening from Greece, dear members and organizers and attending researchers of Conference World in London. My name is Nikolaos Zafiropoulos, and I am a member of researcher group DAC from the University of Piraeus. Today's presentations aims to highlight the problem of chronic disease, a stroke, using machine learning models. However, it is an extension of how we understand the data and how good it is and whether we can improve in combination with the truth index results. The contents of today's presentations are as follow. First, we can start with an introduction to the meaning means big data and ML, and continuous machine learning principles and machine learning index in the healthcare domain, and continuous overall mechanisms architectures and functionalities of these mechanisms, and the dataset experimental results and final conclusion steps. Introduction, according to the World Stroke Organization, 5 million individuals experience stroke each year, and with 6 million of them dying. Stroke has a profound impact on many aspects of life science. It is the second leading cause of death and the leading cause of disability worldwide. And it is a compatibility medical issue and is a critical to spread the word that is curable. And the solution to this challenge is provided by utilizing ML to develop intelligent models with specific algorithms for real and effective stroke diagnosis. Use the plethora of models, SVC, support vector classifier, KNN, logistic regression, random forest, XGB classifier, and LGBM classifier. The big data analytics based on strict analytical evidence and same the structured and unstructured data, and includes various data operations. Big data include the artificial intelligence, ML, deep learning, and other. But the artificial intelligence impacts human intelligence to machines and used by the logic and decision trains, and includes ML and deep learning on the other. But the specific machine learning subset of AI use the statistical models and experiment results with different metrics, accuracy on the other, and machines improve with experience to predict. Machine learning principles, the solutions to this challenge is provided by the utilizing ML to develop intelligent models for real and effective stroke diagnosis. The current study is built on applying ML to predict the occurrence of a stroke and then identifying the most effective and accurate models based on the predictions. Following that, exploratory research is conducted to evaluate the performance and retrieve the findings of a variety of ML algorithms. These 6 ML models previous before, assessing the extracted results of each algorithm, debating the validity and the accuracy of their findings before selecting the best one algorithm. Machine learning in healthcare, the first step to select the patient demographic data, clinic basic data, or past clinical decisions and outcomes. And the second step to apply this presentation mechanisms data analysis. In the first step, clean data analysis different from a clean component in scientific, and model training. Next step, featuring importance, and finally predictions results to stroke or no stroke patient. And finally, clinical decision support with recommendations between patient and clinic. In this image, we can see the architecture of these mechanisms. We can use the different dataset. In the specific path, use the stroke dataset from the Kaggle in the next slide. And the continuous gateway component collect data and save to the MongoDB results in a specific collection to analyze this result. And next, clean data analysis for use the specific ML models Orchestrated experiment, same is the data profiling, summary of the data, label encoding to used for the numeric data because the ML models used with numeric and not string, and continuous model training with 6 ML models. And the next step, model evaluation and validation in specific algorithms with different metrics, and save and continuous collection model registry in the different collection of analysis result in the MongoDB. And continuous, we can see the feature importance, performance, and finally we can use prediction from these algorithms. Mechanism functionalities is accuracy. True positive case is referred to the true class that has been classified as true. True negative case is referred to the false close to the classified as false. False positive referred to the false class and is classified as true. And false negative referred to the true class and been classified as false. Precision. A metric relates to the percentage of exams identified as positive by the classifier that are actually positive, with a focus on samples mistakenly classified as positive. Recall sensitivity. This metric, which is the percentage of positive instances found by the classifier. As a result, this course contains the samples for that the algorithms failed to accurately categorize. FNA score, it calculates the weight harmonic mean of recall and sensitivity and accuracy, which refers to FNA score. And final confusion matrix with values in the main diagonal, which the correct predictions, and while the remaining cells show the incorrect predictions. Use dataset stroke for McCaggle, and this dataset contains 5,110 records, which these records 4,861 records are predicted the corresponding patient not to have a stroke, and other records to have a stroke. In this dataset, used with ML algorithms, because the present dataset has 5 columns with strings as data type. Okay, all these strings have been encoded to numerical type, and as a result, as protections, confusion matrix, and estimations of the most significant attributes evaluated by the algorithms, to which with notation applies were applied. In these different algorithms, we can say in the most important feature is age, the top, and the better from the second characteristic, gender, and other way. And this, we can see the algorithms with confusion matrix to make diagonal accurate predictions true in different ML algorithms. Finally, this study investigates whether the outcomes of various ML are true and they're realistic or not based on various metric functions in order to ensure that they extract efficient and accurate results. As a result, it was determined that developing an ML model that may help in the early prediction of stroke and limit the severe long-term image was critical in this work. And this study also demonstrates how effectively various ML systems anticipate strokes based on a range of characteristics. And finally, choosing the best algorithms is a difficult issue because the study provides a technique that well-known ML algorithms and compares them in specific researcher or specific employees in healthcare. them thoroughly to choose the most efficient ones. This research leading to the results presenting this paper has received from the European project I help, and is financed by the European Union and Greek national funding Be Healthier to use in the specific mechanisms previous description. Thank you for your attention. Any questions?
Yeah, Nicholas. Are
Yes.
you hearing me? You have
Yes,
done,
yes, yes.
yeah. You have done a great work for stock risk prediction using machine learning algorithms. You have used support vector classifier, KNN, logistic regression, XGB classification, and like that. Now, my query is, which algorithm is efficient in your case? Out of all these?
The best algorithms for this mechanism is random forest because it is a Boolean result to decision if a stroke or is no stroke, because we have not more classifies, and we can see from this confusion matrix in the main diagonal
You have
random
discussed
forest.
all the algorithms. You have discussed about all the algorithms, and you have presented all the results. Exactly what I want to know, which one is efficient in your case? Out of all these, KNN, SVM, LR, RF, XGB, out of all these algorithms, which one is efficient?
We can
have you
we
checked
can use
it? Have you measured the performance?
Yeah, check it with different metrics before previous accuracy, precision, or recall sensitivity, but with no timing for this presentation, we can see,
I think,
check these algorithms, it's okay, and other, but it's this data set
okay.
use specific decision trees classifier, different.
Okay. Now, and within your experiment, you have calculated F1 score, harmonic mean of recall accuracy. You have calculated it. Yeah. So how it is calculated? Harmonic mean of what?
Okay, it's
you have calculated a weighted harmonic mean. Means harmonic mean of what? What kind of data you have taken for this?
Because this statistical metric used this typo, and the expected result from the accuracy and recall used in this typo, precision. Okay, we can use in the export reference metrics in this chart, accuracy, precision, and other. FN score.
Within your experiment, you have taken 5,110 records for health conditions.
Yes.
5,110 records you have taken. And for that, you have calculated the harmonic mean of all these data from you have taken. Okay. So just my question is what? You have taken the same kind of stroke or a different kind of disease strokes you have taken within your experiment?
Okay, but in this data set or a different data set, have records 50-50 records to use educated algorithms with no stroke or non-stroke, because 5,000 records and 50% records have a stroke, and other with a stroke, to predict better results for these algorithms. and we can see different characteristics. So it is feature important. In this point,
How
this
many test
mechanism.
cases you have taken for a brain stroke? How many test cases you have taken for a brain stroke or a neural stroke or heart stroke like that? Can you classify it? Or any kind of strokes you have taken, including within the 5,000 data or in the 5,000 records?
Yeah, and more and more instances and more records for this data set or other. It's a better result for these mechanisms because it's a little records, and these results we can see, and the more records, age and gender and age is a feature importance with work type or other BMI.
Okay. Thank you.
If no, okay.
Basically, within your experiment, you have taken only one kind of strokes, that is a heart disease. Means you have taken a heart disease or hypertension like of data you have taken. You haven't taken about the brain stroke or a neural stroke or kind of that. Means only you have studied the strokes related to heart. I think what I get from your experimental results. Anyway, thank you. Thank you so much.
Thank you.
Thank you so much. So our next presenter is a visit, and the paper title is an object-oriented agent framework for SCADA.
Can I start now?
Yes, sir, you can start.
All right, thank you. Okay, let me share the screen. Can you see the whole screen?
Yes, sir.
Okay, good, thank you. Good afternoon over there. My name is Visit Hirankiti from King Mongkut Institute of Technology, Latkapam. In this afternoon, I will present my research work on object-oriented agent framework for SCADA. So the topic that I'm going to talk about, first, I will introduce what is a SCADA and its functionality. And after that, we'll talk about some research work, related research. And after that, we will present our architecture, object-oriented modeling of our agent-based SCADA, followed by the modeling of the object and state and framework, and finally, some result and conclusion. Here is a SCADA system. Any SCADA system will consist of the hardware that are machined in the factory. In this picture, we have robot motors, and then there's going to be a computer that connect these devices. And the software that's running on this computer, we call it SCADA, that it will control these devices in the factory. So its basic functionality is it connects the devices with a communication network. The software would read-write data from these devices, could be sensors, and then it will monitor and control as well as display the data that it monitor and control on the dashboard. The software also store historical data, what the machine is operating. The user can interact with the software via touch screen like you see there. We call it SMI. And the SCADA also alert the user when there is any problem with the machine. There's some research similar to what we are doing. The first one is by Losha and Sko, doing some conceptual design using object-oriented as well. But for us, we go further for the kind of intelligent SCADA. We also model it using object-oriented approach as well. The second work that related to us is to use kind of logic by Shadowwood and their colleagues. It's about agent framework that apply to SCADA. This work make use of agent language called agent speak, and it also make use of uncertainty. But for us, that doesn't support uncertainty. We prefer to stick with the classical logic to apply with rules, and their work also make use of rule, but they have uncertainty information as well. Here are our early works on agent applied to smart home and SCADA. Right now, when we upgrade SCADA software to have intelligent capability, so what the agent would do for this, the agent can reason about the present state of the device in the factories. And this state, we have the rule that check whether some condition is satisfied. If it satisfies the rule, then the rule can activate to perform some action. And all of this state that the agent would reason about, it can be used to alert the user, or it can also detect whether there's something wrong with the machine and able to control it in a way to prevent any kind of problem. And it uses the agent way of reasoning. Here is our architecture. It contains 6 components. The first one we call it worker. Worker is a low-level language. We use Python language and C language to implement it. It is a program that connects device to the SCADA, and it deals all kinds with kind of communication. The data that feed from the worker will be passed into what we call real-time database, and we use Redis as a way to store it because it's very fast. It's on the RAM of a computer. We also have the WebSocket that maintain the connection between SCADA and the device, so that it allows the device to be keep connecting with the SCADA and be able to pass the data between the device and then the real-time database. The data will be put through the GUI via the web socket as well to display on the dashboard. We also have server side, which is the part of the agent that we implement, and also the client side, which is the web to display the dashboard, and we can also use it for human interaction. And we also have a database that to store with objects. We use an object database to store device represent as a Python code. Okay, let's now move to well, why we choose to do object-oriented modeling of SCADA. We argue that the object modeling is the most intuitive way of representing what we call the digital twins. because with the SCADA domain, it works with the real world objects. And the real world object can be represented as a digital objects. And this is what we call digital twin. That means what is going on in the real objects, it's gonna reflect into the object, which is in the digital world. Secondly, with the object-oriented modeling, we allow to talk about object language and the meta language. Object language is a language that represents the devices, the system, but the meta language is the language that describes the metadata of the object language, such as widgets that we can use it as a representation of how the real object behaves. We could call it avatar, you know. And this avatar can be displayed in 2D or in 3D as well, when we talk about metaverse world. Firstly, the object-oriented language concept is very rich. We can apply concept of abstract class, inheritance, and it's also allow logic to be used for representation as well. Here is our class diagram. We separate between the object language, which is the below here, that is talking about communication. And on the left-hand side, we are talking about system devices. And on the meta level, we can represent the avatar or kind of representation where we're going to use data of the object language to be presented to human. And also human can use.
Sorry for the interruption. You have 2 minutes left for the presentation.
And can you hear me well?
Yeah, sir, you have already.
All right.
Yes, thank you.
Okay, right. We also use an agent to reason about the meta language as well. This is how meta language, object language would be used. The object language will be Python code, and the meta language is the TUI part and the agent part. Here, how we model the device objects. The device object would create from class using meta programming. And then each class gonna be used to create objects. Once the device update the data via the communication, it will update the state of the objects. You know, when it updates the state of object, it moved to a new state of object, just like in this diagram. And we can use logic as a way to represent about each property inside the state. For example, if we want to say that the brightness of the light bulb is level 10, we can say light bulb dot brightness equal to 10 or something like that. And we can use that in the world of logic. Here is our agent framework. It consists of system, it consists of server that observe the data from the machine. And it's stored in the state history. And when we talk about rule, we means event response rule. And it represents as a condition like this. If some condition is satisfied, it's gonna do something like here, if the light bulb turn on, well, if the light bulb already turned on and now it reached 6 p.m., so the rule is gonna be true on the condition, and it will trick this rule to do turn off of the light bulb. And finally, we also have a constraint to apply to the device as well. This is how the agent works. It keep monitor and update the state, and it apply the state to the rule. If the rule is activated, it's gonna execute some action, and this action again update into the state of the object again, and it is go like a cycle. Yeah. We have applied this our implementation, the development using Python to develop a prototype of a SCADA, and it's running on Raspberry Pi tablet, like you see here. This is the dashboard, and it's also used for developing a smart meter as well. in this example, we have a meter, one device, and the light bulb as a device. And then we can interact with it. And everything that I explained using the class diagram, we exactly develop it into Python. So what we got into the result of our work is that the SCADA framework is developed entirely using object-oriented modeling, and it reflects the concept of digital twins, and it also emphasized the significance of the reasoning about object level and meta level. So we believe that this OO representation would allow us to be able to apply to logic, and in the future it will combine with logic. Thank you. Thank you very much.
Yeah, Hirankati,
Mm-hmm.
you have developed an object-oriented agent framework for a SCADA system.
Mm-hmm.
Great job.
Yeah,
First of all, just my first query is, have you developed any agent for this SCADA?
Well, agent for SCADA is quite universal. So you can think of smart home is a kind of SCADA by changing from system into the device in your home. And for me, we also develop a smart meter, rather than device in a factory, we just change it to the sensor in the smart meter. So it actually is applicable to any IoT system at all.
Okay, so you have used a universal agents.
Yeah, it's kind of generic.
Okay. Great,
Mm-hmm.
great. Okay, how object-oriented modeling is useful for a SCADA?
Well, it used to model the object level with any kind of devices in your system. If you have a light bulb, you're going to represent is an object in Python or in a object-oriented language. So it's going to be something like device, and light bulb is an object of device or something like that. So the code of your object-oriented language and the name of the device is going to match with one another. We have a bank account, we have an account in the real world, and we have a digital account in the virtual world, something like that.
Basically, as we all are aware that there is two problems with SCADA.
Mm-hmm.
Like SCADA is complex.
Mm-hmm.
One. Second,
Mm-hmm.
installation cost is higher with the SCADA.
Mm-hmm.
Have you done anything with SCADA? Means have you reduced the complexity, or how we reduce the cost of installation? So have you worked on that, or you start working on object-oriented modeling?
Well, what I have seen that about SCADA, I don't think it's complicated. It's hard because it has to deal with many objects, something like 1,000, 10,000. So that means if what I'm doing is that I developing SCADA that can handle on hundreds of objects, for example, and I use the scalable. I make many objects that many agent. You could have agent one that take care 100 of objects, another agent two take care of another 100 agent, or something like that. At the end, my SCADA would run on something like cluster computer or something like that. So you could think of having 10 Raspberry Pi, and one Raspberry Pi would handle 100 objects, and the other another object, 100 objects or something like that. So the complexity is about the scalable of how the SCADA would manage or handle a large amount of devices in the system, but the functionality they are similar.
Okay, great,
Mm-hmm.
Great work.
Mm-hmm.
Thank you.
All right, thank you, sir. Is there any more question?
Yes, sir. Thank you very much for your kind presentation.
All right, thank you.
So all presentations are done. So I sincerely thank our all authors for their great presentation and contribution to this session, and all our participants for being a part of the international conference. I hope this session was informative enough to all. We, on behalf of the whole team, thank you so much for your support in this version and previous 5th version. We are happy to have you in the 8th version, 7th version of this conference. All the presenters would be getting their digital certificate within a 2 or 3 working days through mail. Further, all the preppers have already submitted to the Springer, and publication will be live within a 5 to 6 months. So kindly cooperate with the team of WS4. Now, I also thank our chair of the session, Professor Om Prakash Rishi. Sir, thank you so much for your valuable presence, and here a token of appreciation on behalf of Global Knowledge Research Foundation and team WS4.
Thank you, Riddhi.
Yeah.
And thank you so much, all the participants. You are wonderful researchers. You have done a great job, and you are doing a really marvelous work for the research in the computer science. For example, weighing done a robot wheel controller system developing on that. And Vasilis is doing again a great job on earthquake monitoring and MEM sensor. Similarly, Anika is developing data medi systems. Again, a great job, although this is simply a software development. And Nicholas, who is developed a stock risk prediction system with the help of a machine learning algorithm. And again, the last presentation, which is made by the Hiran Kiti, which is an object-oriented agent framework for a SCADA software system, which is a recent technology for the which improve the efficiency and productivity to reduce the cost and waste in the industry. And really all are remarkable or wonderful, all the authors. Thank you so much. And thank you GR Foundations for inviting me as an session chair. Thank you so much, all of you.
Yes, sir. Thank you so much.
Thank you.
Yes, sir. So at the end of the session, I request to all, please turn on your camera for a quick snapshot of this virtual conference. Yes. Thank you so much. And stay safe. Take care.
Thank you. Take care.
Yeah.